Hello, I'm Anawiltos, and today I'm going to be talking a bit about gravity. And what I have to say today is that it turns out scientifically that heavier objects generally do fall faster than lighter objects. And you may say, well, that's not actually true because of inertia and air resistance, etc. But I'm here to tell you that it is true, and I'm going to explain to you exactly why it's true. So there's a few different factors you have to think about when you're dropping an object. Let's say the two objects that you're dropping are the same shape. So let's take maybe a cannonball made out of iron and a cannonball made out of lead. And of course, the one with lead has more mass, it's significantly heavier, and it is the object that in this experiment I will predict is going to hit the ground faster. Now, of course, in order to do this experiment properly, we're going to create an artificial system wherein the mass of the planet that the objects are dropped towards is always the same, regardless of which object we're dropping. And also, in order to prevent contamination in the experiment, we're going to be dropping the two objects independently, hypothetically, in this thought experiment. So you can drop an iron cannonball towards the Earth or a lead cannonball towards the Earth. So there's a couple things you have to think about. So of course there is the acceleration due to gravity, and of course that depends on how far away you are from the planet. But assuming that we're dropping the objects from the same distance, that's not really going to be a problem here. So the acceleration due to gravity of the object towards the planet is going to be the same. Now we also have to think about air resistance, and I'm going to be honest here, heavier objects have more inertia and are capable of overcoming air resistance more than lighter objects. And therefore, if you drop a heavy object if you drop the two objects from a high altitude, the heavier object will hit the ground first. That's just a simple fact. You wouldn't expect a feather to hit the ground first. You wouldn't expect a man with a parachute to hit the ground first. So we can have an obvious example. Two men jump out, they're the same weight, same size, but one of them deploys a parachute, the other one doesn't. The one that doesn't is going to hit the ground first because there's less air resistance. And there you go. Also, the effectiveness of a parachute can be affected by the weight of the object that it supports. So if you've got a parachute and a really heavy object, it's going to pull much harder against the parachute with its weight, causing it to potentially fall a little bit faster or to have a breakdown. Alright, next step, inertia. Someone may say that, of course, inertia is greater in a heavier object, and that therefore, due to the inertia is going to prevent the object from accelerating faster than the lighter object. Therefore, they'll hit the ground at the same time, or to be more exact, in the same time span, since we're not dropping them at the same time in order to prevent cross-contamination with gravity. However, the big thing people are missing here is that gravity is exerted by all objects with mass. So right now, until now, we've only been talking about the cannonballs that we're dropping. But what about the planet that we're dropping the cannonballs on? Now, regardless of whether the planet has an atmosphere or not, so if we want to get rid of air resistance, we can just say the planet doesn't have an atmosphere. We end up looking at the planet and the planet is being pulled towards the cannonballs to a very slight degree. Now, of course, planets are very large, so they have a very large inertia, which means that, generally speaking, that type of pull is not noticeable. However, it still exists. Just because an object is small doesn't mean it doesn't have a gravitational pull. So, we take that large planet, and it's being pulled towards the two objects. Now, the two objects have different gravitational pulls because they have different masses. Objects with a larger mass have a greater gravitational pull. And therefore, if we assume that the planet has the same inertia in both situations, then we understand that it's going to accelerate more towards the heavier object, since the heavier object, assuming the inertia of a planet remains the same in both situations, will have a greater gravitational pull on it. And therefore we know that heavier objects have a smaller closing time, or a smaller time span for the objects to hit each other than lighter objects. In other words, heavier objects do in fact fall faster. And that's taking into account air resistance, that's taking into account inertia, that's taking into account gravitational acceleration. All those taken into account, we know that heavier objects do in fact drop faster. And you can look this up on the internet. It's not something that I made up. There's hundreds of people out there that will argue the same point, and there's also hundreds of people out there that will argue against my point. However, if we take inertia into account and we know that every object has a gravitational pull, and that assuming the gravitational pull is the same for the planet in both situations, but that the gravitational pull exerted on the planet by the two objects is different, we know that heavier objects will collide with the planet faster when dropped from an equivalent distance to a lighter object. So that's all I really had to say. If you disagree, please say so in the comments below. If you want to learn more, I can probably refer you to a source that discusses this. So if you want some sources, I can give them to you. And that's all really. Maybe I'll just put the sources in the description. So thank you all for listening, and I'll be seeing you all next time on Awiltos over and out.